My name is Tarannum. I'm currently pursuing my master's in IIT Kharagpur. And this work is about a framework socialLens to unveil loneliness levels using multimodal data. So, my project instructor is Professor Bivas Mitra, and this is funded by AI for ICPS, where the project director is Professor Niloy Kamkar. And this work is funded by them. So let's know what is loneliness. So it is a feeling of disconnection or feeling of void, a very subjective feeling that a person goes through, and it is different from the social engagement and all. It can be voluntary, it can be involuntary. So even a person can feel, even if the person can feel like sitting in the public, or a person can feel alone when the person is alone. So the thing is that I'm showing the scenarios in general setting. The person is sitting in a bus and being around the people, but still feeling lonely, and at workplace. So how it affects. So in institutes or in workplaces, suppose if we have employees or students going through this certain mental health conditions, that is going to impact their productivity as well as their performances, and that will reduce the hamper the productivity of overall organization. So let's look at some statistics that I got. So 1 in 3 adults, they go through feeling of loneliness. We got it from the World Health Organization report. Nearly 45% of the urban Indians, they have certain lifestyle, they go through this loneliness, mental health conditions that is going to impact their overall mental health, driving them towards depression, anxiety, and many more health conditions. So that's why that was a motivation to learn to actually detect loneliness to prevent certain severe health conditions. So what are the challenges in the previous research? So previous papers, they want to study loneliness as well as social isolation, but they are blurring the line between them, using these two concepts interchangeably. So loneliness is a very subjective feeling that is related to someone's emotions, bodily changes. It is very much related to that. But social isolation, on the other hand, it can be lack of socializing, it can be lack of social engagements with the environment. And second point is conflicting findings. So the paper, they are trying to find the loneliness. Certain people, they say that it is very much correlated with their activity a person is having throughout the day. It can be, some people are saying that no, there's no such correlation between activity and loneliness. So we have to find a common ground. We have to affirm these things and relying on digital data. So as I said that they tend to study social isolation, but they mix it with the loneliness. So they capture digital data, which is privacy breaching, like your phone calls, your SMS, your emails, your browsing history and all. I just conducted a simple survey, a Google form I shared with the people there in IT Kharagpur, and asking them what kind of data you really feel that you feel uncomfortable sharing with the people for research studies. And I have these modalities, digital activity called SMS, microphone data, GPS data, phone sensor data like accelerometer, gyroscope, humidity sensor data, and health data. Certain smart watches people wear, and we can access their health data, right? So heart rate, EDA, skin temperature, and we can see that the people mostly said that yeah, they are not comfortable sharing their digital data for research studies, microphone data. But we have seen that, okay, there's less concern sharing certain data like GPS, phone sensor, health data. So we wanted to design an experiment in such a way that we will carry out our data collection study, which align with their privacy concerns. So here are our research goals. We wanted to have a robust data collection framework where we are going to collect data which will align with their perception of privacy, and which could be quality multimodal data to understand, study loneliness in its own context, and not different from the social isolation here. So we had a work going on explicitly for social isolation, having a solution developed for that, and we filed a patent with that. So right now, let's go with this. Okay, so we fusion this multimodal data coming from the wearables and this to have a machine learning model to detect loneliness. For our data collection phase, we collected data passively as well as actively. From the passive data collection, we recruited 15 participants and instructed them to wear a Fitbit Sense 2 device to track their to track their health data. And we instructed them to install our Android sensor app to collect some of the activity signals through their mobile phones. And we did have some privacy measures that we are not going to collect any digital data from their mobile phones. And the motivation behind selecting this Fitbit Sense 2 to collect health data is it's very non-invasive. People can wear this every single day because the experiment was longitudinal. For it was carried out for 4 months, and yeah, we recruited people from different age groups, uh, 20 through to 57, from different background, corporate, business, retired, from different like occupations. So these are the modalities I'm showing the right side, that heart rate, sleep, EDA, temperature, and activity we collected from both of the devices. And the motivation for selecting Fitbit Sense 2 especially was that we were not getting from the other commercial watches. And if we went for the research or built watches like in Patika, it would not have been economical. Hmm. Apart from the passively data collection, we actively collected ground truths from them. So we used UCLA survey questionnaires for the loneliness, where we have simple questions like I feel in tune with the people around me. It is kind of positive questions. I feel a part of a group of friends, and there are options like never, rarely, sometimes, and often. On the right side, there's a snap of our application where we developed to collect the simple surveys. Every single day, the user has to fill up this survey, and we calculated a score based on these questions. Lower level of loneliness for that day. And this is a snapshot of how we classified these scores to three different classes: low level of loneliness, moderate level of loneliness, and high level of loneliness. So it is a multi-class classification problem. These are the socialLens framework overview. So we have data collection part, where we are collecting data from Android sensor, Fitbit Sense 2, and a survey app. Then it goes through this data pre-processing and feature extraction pipeline, where we are using techniques like noise filtering, normalization, and class imbalance. Okay, so let's look at the noise filtering. Like we have signals like ECG, EDA, electrodermal activity, accelerometer. So we want to remove the noise from these signals. So for signal processing, we use low pass and high pass filter techniques. And for each day, we aggregated the data points to a single, we aggregated the entire data to a single data point. So normalization to normalize the scores for our machine learning model. And then we address the class imbalance technique, because out of 15 people, there were certain people who were not at all going through this loneliness feeling. So I was getting the survey scores like low, moderate, like that. I was not getting the loneliness, higher loneliness data set. So that's why I tried to use the technique, smart technique, to synthetically generate some of the data points for those people. And then we use stat max mean, so to calculate the core features from these signals. So these are the modalities I'm showing: heart rate, sleep, skin conductance, respiration, and mobility. In the mobility, in the heart rate, we have HRV, heart rate variability, resting heart rate, sleep score, restlessness, EDA, skin temperature, respiratory rate, accelerometer, gyroscope, steps. We also had steps, calorie count, etc. So these are the multimodal features that we could come up with the data set, and we selected 102 highly good features from this data set, and we calculated survey scores from the surveys, and then we had a very simple ensemble learning model, SVM and random forest for this. And let's look at the results. I want to add one more thing, that this model is going to run in the cloud. So we are going to deploy this in our smartphone and give up all the privacy concerns, because we are collecting data in the backend from the users. But we will address the privacy next, the next works. These are the results. So we have tested our model on 3 different variation of data sets. First one is having this physiological signals only coming from the Fitbits. Second data set having only the activity levels, steps, accelerometer, everything. And we had a fusion of both features. So on this data set, our model performed well. I'm showing the results for 8 participants here. And these are the results, and we could achieve a very decent accuracy. On the other hand, I also developed an aggregated model in the cloud, and these are the test accuracy on the right side. We could achieve a maximum of 93.75%, even in a generalized model. These are some of the observation that I saw, that I tried to have an accuracy chart for based on their genders, based on their age groups. So we could see in the left side that the model was performing well for the gender, for both of the gender. It did not have any bias in the prediction. For the people belonging to the 20 to 30 age group and 31 to 50 group, the model was predicting quite well, 97.5% accuracy we achieved. But people belonging to the elderly group, like 50 plus age group, our model was achieving slightly lower than the other age group, like 85% we could achieve. So we can see that perhaps we have only 2 elderly people in our out of all the 15 participants. So perhaps we have less data. It is underrepresented. So perhaps we can come up with a better data collection framework that can collect data from the elderly population, and we can get the quality data set from them as well. Right now in our data set, they are underrepresented. And another thing is that we analyzed features from each and every modalities for 5 participants. I'm just showing this 5 participant chart here. And the observation is that not all the modalities, not all the features are going to work for all the subjects. Like for subject 1 here in the left side chart. Sorry. Yeah. So in the left side, the sleep score is a very determining feature for the subject 1. However, it is not for the subject 4. If we see, the value is lesser here. So we calculated the feature importance score, just to check how the model is performing and what are the features that really qualified for these users. And we had this personalized model concept because we knew that not all the features are going to work for everybody. So we had a personalized assessment. And this is the feature importance that is coming from the aggregated model, which means that these are the top features which is performing well for all of the participants. So this resting heart rate, sleep related features, activities features, and the heart rate variability, your heart rate features. This actually performed well for all of the 15 participants. So these are the future directions that I want to expand my feature diversities, want to include more data from different age groups and genders, so I can make my model more robust and improving the robustness of model and providing more privacy preserving solution. Right now, I'm just running the model in the backend because of inference latency. And then I'm deploying the model on the smartphone. So I have developed one more devices. It's an edge device where we can run a more sophisticated deep learning model to do the same job, and which actually waive off all the privacy concern. And that work was recently accepted in ACM SAC 2025. But still, there's a lot of things we can do for the elderly people as well, who are going through loneliness, and they feel loneliness differently from the other age groups. So we want to capture those nuanced patterns. These are the references, and thank you very much.